Morning, doctor.
Morning, Doctor.
Okay, let us start our session this morning. A moment silence, remembrance our God first. Father. Okay, today I would like to review on Solid 1 again. Solid 1 and stress analysis. But before that, I do for the last time. I would like to explain to you how to do the Mohr circle, the most easiest way. You seem still not very confident that one. You're still using XY, XY, XY. When there is 90 degrees, but not XY, you are not very confident. So you waste a lot of time. Okay? Let's look at the example homework that we have for the 9-2. Homework 9B, right? Homework 9B. What is the first? What's EA, EB, EC? Somebody told me. I forgot.
EA 40 degree, 200 microstrate.
200. Yeah.
EB 90 degree, 100 microstrate.
100 EB here.
Uh,
100 microstrain. Again, EC.
EC 130, negative 300.
130.
Ah,
So that is 90 degrees here, right?
yeah.
EC here. So the value is negative
Negative 300.
300. Yeah. So this is 130 degrees here. This is 40 degrees. Yeah. So if I solve it for gamma AC over 2, what do I got? I use the A here and C here. I solve for gamma AC. What is gamma AC? Your homework.
I didn't do gamma AC. I used
From
gamma
the Mohr
AC.
circle, you can read. You can read that from the Mohr circle.
196.4 microstrate.
Positive.
Yes.
196. Yeah. Gamma AC over 2. Okay, look at this. So if I plot the Mohr circle by AC, I just saw one equation there. What are the one equation there? E theta is equal to how many degrees here? 50 degrees, right?
Yes.
Theta is equal to 50 degrees. The value is what? 100 is equal to 200 minus 300 divided by 2 plus 200 minus is plus 300 divided by 2 cos 2 theta cos 100 plus gamma AC over 2 sine 100. Just one equation here. You can solve gamma AC. Is that correct?
Yes.
Everybody?
Yes.
Just one equation, right?
Yes.
Okay. And then I write down what is A. What is A point? 200 and what?
Negative 196.
Negative 196. And then what is C there? C point direction is what?
Negative
Minus 300.
Positive 196.
This is basic information here. Then what is the Mohr circle there? Very quick there. 100, 200, 100, 200, 100, 200, 300, 100, 200, 300, 300, 300. Yeah? This is your normal straight is gamma over 2. Very quick here. See that? I want to plot A and C. A and C, 200, negative 196. 200 here, negative 196 somewhere there. So that's your X. Sorry, not X, your A. And then your C is negative 300, 196 somewhere there. That's your C. Draw a line there. Got a more circle. Center there. What is the center there? 200 and 300. Total is 500. So this is 250. This is 250. 250. This is 196. What is the theta? What is the radius? What did you get last time? Or your radius? The same things. X, Y, same radius. What's the radius, please?
317.7.
317. And then 2 theta is equal to what?
38.1.
Say what?
38.1.
Yeah. 38.1. Yeah. Now, you know A and C there. And then you can find 1 there. You can find 2 there. So your center must be what? 250, 200 is minus 50 here. Minus 50, 0. Your center position. 250 there. And from here to here is 317. So what is your E1? E1 is center. Center plus radius. Your center is minus 50 and plus 317. So what you have there, positive 200.
267.
267. And then you got E2 there. Center minus radius. Minus 50 minus 317. It's minus 367. So you got a very quick answer there. So what is most of your problem now is that you don't know how to use this Morse circle. Morse circle technique is the easiest one. You have to understand this, how to put your X there. Where is your X there? You must put your X there. Where is your X there? Where is your X there? Read from here. Where is your X?
Negative 40 degree in real life.
So,
In
clockwise
most of
40 degrees. So this one must be
clockwise 80 degree.
clockwise 80 degrees from A. See that? This arrow should be shown there. So you understand that must be there. There is your X position. And then your Y must be there. So you know this angle, you know that 90 degrees. So you know that is 80 degrees. Because this is 40. 80 here. So you know that triangle. So you work with the triangle there. This one triangle there. This is 317. Your angle here is what there? 38, 80, 118. So what's the angle there?
61.9.
61.9. Very easy. This value here, that value here, find the value. Minus 50 plus the value, you got that one. That is EX. And then, when you do this one, you know this one, you find your Morse circle, you convert it from E1 to sigma 1 and then sigma 2 there. And then the first sigma 1 and sigma 2 from. Then you got a Morse circle of sigma there. This is sigma 1. This is sigma 2. What's the value there?
Sigma 1 is 34.6.
34.6. This one is
Negative 63.2.
negative 3.2. It's not finished like that. Doesn't finish like that. The question says, find the stress on angle. What's the angle there? 30 degrees, right? Are you with me?
Yes, 30 degree.
You can name this one any name. A name, you can name it F. You can name this G, whatever, FG. You must mark here. Where is H? Where is A? Where is G? Where is H? Where is A? Where is G? That's the most problem of you. You don't care to finish all this analysis there. Just answers. The process, you don't care. Because it's very, very simple. And then where is that one? Here first. Where is that direction? Even though this is stress, I don't care. This direction is where here? From X, 30 degrees. So your F here, 30 degrees clockwise from X. Your X is 30 degrees. So there must be F there. So this is, you show that angle there. That is 60 degrees. 60 degrees from X to that one. That's how things work. And then you can find the value there. Triangle again. And F there, and then must be G there. That triangle, that one. Draw the triangle again. Very easy. Same thing here. When the triangle, when the more circles like that, this is your sigma 1. Where is that angle here? That must be your X. You must show that one. Where is your A? Your A must show that one. How many angles there? How many angles there? And then where is your F? Must show that one. From here to here, how many angles? From here to here, how many angles? F. And then you can read the value there. See that? The X position, the F position, the A position, the 1 position, A1, F, X must be shown here, must be shown here. Are you with me, guys?
Yes.
Very easy. Don't mess up for this. This is very easy exercise. You must understand how this one. But the process must be shown. The angle must be shown. The triangle must be shown. Don't mess that. Show it outside. Are you with me, guys? Everybody of you. The more circle is the easiest one.
Yes.
Why are you afraid of A and C? One equation only. Because you are not confident with more circle. You just XY again. XY again. You can find AC and then you can find XY. Why not? Easier. Are you with me?
Yes.
Everybody of you, challenge yourself to do that, whatever method that you want. And then you can compare which one is shortest time. So this is the shortest time. You can save a lot of time. Okay. Today I want to review the strain, convert to stress. We have done that one. So you know the relationship. The forward equation, backward equation. Correct? Today I want to review the solid one again and stress analysis. Because most of us start with this one. Because most of the exercise in the book start with given one. Correct?
Yes, correct.
Actually, the work doesn't start here. The test and the exam won't be start here. We start from the beginning of solid one. Are you with me?
Yes.
For example, in solid one, we learn about the thin cylinder. Thin cylinder. So what is thin cylinder? Coke, tin coke, Milo tin. If we have a pressure inside, just like piping. Okay, we have a We have a thin cylinder there. Chapter 4, we have a thick cylinder. So this is thin cylinder. The pressure inside. Close here, close here. So what do we have? When you close here, the pressure push. If you look from the side, pressure push on the left. So what happened to the body, the skin here? The body skin here, if we cut there, cut just one side, what happened there? There must be stress along that direction, correct? Are you with me?
Yes.
So how do we calculate this? Summation of force. If you don't want to remember the equation, what do we have there? Pressure times the area inside there. Pressure times the area. Summation force in X equal to 0. Very simple, static analysis. Force to the right. Pressure times the area. The area is what? Pi d square over 4 or pi r square. Correct? Just round circle the area inside.
Yes.
To the right, right? And then the stress to the left, where we cut it, stress times that area, stress times the area to the left, minus stress on that direction, we call it longitudinal, times that area. What's the area? Area of inside minus area outside, right?
Yes.
So in other words, how can I write that area? We can write that pi d pi r outside square minus pi r inside square. We can write that one. Or, because this is very thin cylinder, what if I cut this? I cut that one, make it long like that. This is the cross section there. This is ukulele. Perimeter. What is perimeter? 2 pi r, right?
Yes.
Or pi d, right?
Yes.
The pi d times the thickness, the same as area, not?
Yes also.
Yes. Pi d times the thickness of that very thin, maybe 1 mm. So, pi d times the thin, same like this. So, this one. So, the stress times the area. Because the stress is load divided by area. The stress times the area become the force. This is the force. Force. Are you with me? So, the area here is pi d times t. The thickness of that thin. Let's say we have the thickness is 1 mm. The diameter here, your coke tin. What is the size? Roughly 5 cm. 50 mm, right? 50 mm. Diameter is 50 mm or 5 cm. The pressure inside. Very simple calculation here. So if we rewrite the one is equal to 0 because not moving, what is your sigma L? This one. Sigma L put the other side is what? P pi d over 2 over 4 and then divide by pi dt. Pi cancel out, d square and d cancel out. What do we have there? PD over 4t. See that? Are you with me? Everybody?
Yes.
So we know the pressure inside, we know the stress. If you draw an element there, we know the stress there. Your sigma X is equal to sigma L is PD over 4T. Very simple. And then, how do we know the stress on this side? Because when we put the pressure inside, it's like a balloon because it is getting bigger, right? The pressure make the thing balloon become bigger, right? Same with the tin. Same with your piping. Pressure inside. So we call this direction is hoop direction. Hoop. So how to get your sigma H? You can derive the equation same like that. Same like that. Summation force in Y. Draw the free body diagram like this. But the other way around. Okay? See that? You draw that one. We cut it, and then we cut it. Are you with me there? Or you look from front there, you look from front, you got like that. This is pressure, 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 pressure. And then must be sigma H there. Along that one, sigma H, sigma H, sigma H. The other side, left and right, sigma H. Are you with me there?
Yes, but
No.
I cannot follow anymore. Otak
Why?
blur already.
Why?
Otak blur already.
What blur?
Starting from the sigma x fx equal to 0, the minus sigma L pi dt.
That is finished just now, sigma X.
Uh-uh.
Now we are talking about we cut it in that way. Are you with me? Just now we cut that way.
Okay.
Are you with me?
Yes.
So when we cut that way, we got like this. There is pressure inside there. See that? We want to find the force in Y now, not in X.
Okay.
Are you with me? So when we look from front here, we got this one. You see this one?
I can see.
So the pressure push up there. Half cut that one, push up there. What is the pressure? What is the force? Push up. Force time area. Time area. The pressure time area. The pressure times area push up. Then become force. And then what is pulling down? The body, the skin body, the aluminium can body is pulling down. Because we draw sigma H, that one, in direction of that up H. Hook. So, what is pushing up? The pressure pushing up, what is the area there? Because this length there, there is a curvature area there. So what is the total length? The area must be that length times that length. This is curvature, right?
Yes.
The resultant of area pushing up, how do we calculate the resultant area? We look from down there, the surface area that going up is only flat. Why is the flat? See that? This is up, 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 up. See that? So the total, that one, plus 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 that one. The total is just that length. Even though this curved area there, what is the total area facing up? It's only that length. Can you imagine that one?
Can imagine.
Because this one is the pressure is pushing to the left. This one, the pressure is pushing to the left. I just want the pressure pushing up. So the total area pushing up is just that length times that length. You see that? Are you with me?
Yes.
So the total area pushing up is the curved area. The total area is just like that one. Imaginary flat surface up. And then what is the pressure going up? Pressure times that diameter times length. Length of that beam pushing up. And then what is pushing down? Sigma H. And then what is the total area on the skin that we cut here? We cut there on the side, we cut there on the side, there must be stress there. What is the total area? This is L there. And then the thickness, right?
Yes.
So, two left and right, two thickness, right? So the area times the stress is 2 thickness times the L. So this is pressure times area up. This is stress times area down. This is from the beginning, summation of force in Y is equal to 0. So you draw the free body diagram, you got that equation, equal to 0. And then you solve it. Your sigma H is equal to PD L cancel out, PD over 2T. Tensile, no? Tensile. When the pressure there, this is in tensile. Are you with me, guys?
Yes.
Just now, PD over 40 in direction of longitudinal. The hoop is PD over 2T. So if we draw that nicely, when there's a pressure inside there, when we cut the element there, this is sigma L. This is sigma H. Cut element there. So your sigma L is PD over 4T. This is PD over 2T. You know the pressure, you know the size, the diameter and the thickness. And the thickness of that tin. You got the value not? Who is higher? Sigma H or sigma L?
Sigma H higher.
So both are positive, right?
Yes, positive.
Both are tensile, right?
Yes.
So, how do I draw this in more circles? How do I draw this more circles? This is your X, this is your Y. The shear is 0. See that? Let's say the value here is 30. The value here is 60. Double, because divide by 4, divide by 2. So this must be higher, double than this. So 0 shear 30. And then 0 shear 60. So that is your X, that is your Y. More circle there, center there, got a more circle. Can you see that?
Yes.
So can you write more circle?
Can.
Yes, from the beginning. You are not given this value to write more circle. You have to start from the beginning. If there is something pressure on a thin cylinder, this is how you do it. Are you with me, guys?
Yes.
Okay. Now, what if I do this? I have a pressure on thin coke, put on table, and then I put some book on top of your thin coke. So how you do that analysis there? You do the analysis, the more element there. So this is, in your case, this is not slipping, this is standing. So this is your sigma H now. So this is your, got a pressure inside. This is sigma L now. Can you see that?
Can see.
And then, what about this book? This book got weight not?
Got.
The weight divided by the area, the surface area there, when you cut there, there's the surface area there, that. Correct?
Yes.
Speed divided by the area. So there must be, how you write that one? Element there. This, the positive, this sigma L. This is sigma H. This is sigma H, sigma L. Let's say this value is 30. This value is 60. And then I put weight there. That one, that is sigma Y there. Sigma Y is P over A. Sigma Y is P over A. Your weight of the book divided the area. Weight of the book, let's say 5 kilograms. 5 kilogram is 50 Newton, right?
Yes.
Divide by the area. 50 Newton divided by the area. What's the area there? The cross section of that skin there. Just now. Area inside, area outside, minus inside. Or the simplest one is that. By that. Pi d times t. So you divide that one, you got the value. Let's say the value here is 20 megapascal. Let's say. So how you solve this one? How you solve that one? So the new one, that one is the total one is what? 60 there, and this one is 30 minus 20 is still 10. 10 only there. You see that? 30 and minus 20, that become 10. So it's not 30 anymore, but 10. But there's still 60 there. So the more circle is like that. Are you with me?
Yes.
This is the new Mohr circle if there is a force there. If the force here is more than 30, let's say the value here is 50, but compressive, the weight of the book is so heavy, more higher the stress compressive than the pressure pushing outside. So 50, 20, minus 20. So this become minus 20. This is become minus 20. So how you draw the Mohr circle? 60 there, 0, and then minus 20 there, 0. You got the Mohr circle there. Can you see that?
Can see.
So this is the axis. Are you with me, guys?
Yes.
Very simple, not?
Seems simple.
So thin cylinder, the formula, if you don't want to derive that one, what is simple formula for thin cylinder?
PD over 4T. Is it?
And
PD over 2T.
the other one, the area is what?
Pi dt.
Pi d or 2 pi r or pi d, the parameter time the thickness become the area. Clear now? Very easy, not?
Clear.
So don't when the pressure on the thin cylinder, so this is thin cylinder. So thin cylinder is very two formula only. Why is that? We do this in solid one. PD over 2T and the other one is PD over 4T. So make sure you are using the correct change to meter, change to meter, change to meter, change to Newton. Only then you got the answer Pascal, Newton over meter square. If not, haywire. Are you with me?
Yes. Doctor,
Okay.
the D we can use R
Yes.
also, right?
Say what?
The D, the diameter we can use R also, right? Because D is equal to 2R, then 2 cancel out.
No problem.
Okay.
When you are, what do you have there?
2R.
2R. This is 2R. So what is the
Cancel
value there? PR over T, the other one is PR over 2T. Same thing.
Okay.
Right? Because I prefer to use diameter. Because when we buy things, we never buy by.
Never buy radius.
We always use diameter when buying things. When talk about that thin is, what size is that? That size is 50 mm. That is diameter, not radius. That's why in engineer we use diameter. In mathematics, you're right, because you're used to use mathematics in primary school until secondary school because radius, right? Because your teacher never work outside. People don't call radius. People call diameter is the size. That's the reason. What time do we have now?
10
Yep.
more minutes.
10 more minutes, right? So, never mind. I would like to review for your test one again for the stress analysis. From the beginning. From the beginning. See that? I have a beam there. Pull it. Pull it. Very simple, that one. We are not being given stress X, sigma Y, that one. No. We have to do on our own. What is that one? For test purpose, for exam purpose, we have to we have to find this value in XY, that one. Okay? So let's do this case. Very simple one. P is 50 Newton. Diameter is 20 mm. So, what is the process to do that? The question is, find the strain in that direction. That is 30 degrees. This is stress analysis, not strain analysis. So, at the end of the day, find the strain in that direction. So, what do? We have to draw this one, the stress analysis, that one. So, I've got a sigma x is equal to P over A is equal to 50 over diameter 20 pi d 0.020. Is that correct there? 20 pi d square over 4. So, what is the value there? Stress. Very quick.
One 159 kilopascal.
159 kilopascal. Yeah? Kilopascal. Yeah? And then we got this one. And then what do we do here? More. Circle. 0, 159 there. This is sigma. This is tau. 0, 0 there. You got that one on? Yes. And then you got 159 and 159 there. This 0 there. This is 159 is equal to your sigma 1 is also 159, right?
Yes.
Your sigma 2 is 0, right?
Yes.
Okay. When you finish that one, can you convert into strain? Because this sigma 1, sigma 2 now. So when you do a strain there, convert into strain. You got E1, you got E2, right?
Yes.
E2 is not 0 because we have remember the formula? Sigma 1 divided by minus Poisson ratio sigma 2 divided by E. So we got sigma 1 the value there. We got sigma 2 there because Poisson ratio there, there's a negative there, correct?
Yes, correct.
So this is not 0. There's a value there. Let's say there's a value there. 1 and 2 there. Let's say this value is 28 microstrain. This is minus 10 microstrain. Let's say. So you got a value there. You got a more circle not?
Got.
Got a more circle not? Got a center not?
Got.
Got. Now go back to the question. Go back to the question. In the direction from x 30 degrees. Where is here? You must know your x there. Your x is there. Your 1 is there. You must know that direction there. Let's say your name is F. Can put any name. C, whatever. F. Where is that F? Direction here. Point here. Where is that F? 30 degrees there. Here must be 60 degrees. Show that 60 degrees there. So that point is your F. The other partner of that must be G. 90 degrees to that must be G. 60 degrees there. You must show that one. There's your X there. From X to F, 60 degrees. This is showing that one. And then where is your F there? Same 60 degrees there. So that is your X. That is your 1. So that is your F. And then point there. There's your G. Can you find the value there? Can you find the value there?
Can.
Yes, by the triangle. What do you find there? You know my EF is equal to what? And then EG is equal to what? And then gamma FG over 2. You got the G1 here. Minus something. Minus, I don't know the value there. Maybe the value is minus 12. The EG must be less. Minus 8. And then this one is maybe positive 20. Something like that. Are you with me?
Yes.
Can I find? The question is find the strain value. So just this one. If I want to draw the element, how do I draw? From X, 30 degrees. You got F, you got a G, and then element there. In F direction, positive. In G direction, negative. And then the angle here, You read the G1, negative, bigger, bigger. So that is the element. So EF there is positive, EG there is negative, and then gamma FG over 2 there is negative 12. If he asked to draw the element, if he asked to find the value of strain gauge, only 20 there. Very simple, not?
Yes.
But from the beginning, you must draw it on your own. You must find the value 159 megapascal sigma X. You must know your tau XY is 0. You must know that sigma Y is 0. From the beginning, you must solve it. This is solid 1 until stress analysis. Okay. Again, do a very simple L-shaped beam. Put a load there. 100 Newton. This is 2 meter. This is 3 meter. Let's say I draw an element there, A there. I want to analyze that point top there. So what do we do here? I have to draw the diagram here from I want to see the surface there. I told you from the beginning last time, right? I want to draw the diagram there looking from this side. So I draw that one from that side. See that? This line here is that line. Up here is that up. That line there is that one. So that A here is that one. Can you see that? Everybody, can you see that one?
Can see.
This drawing is a very critical drawing to start your study. Because you can see all the effect there. 2 meter there. 3 meter there. So 100 is 100 there. This become your V. And then 100 times 2, that one, rotating that axis. So there must be resist it. There must be torsion there. The torsion there is 100 times 2, is 200 Newton meter. And then 100 times 3 is bending on that axis. So it resists that one. The wall is resist that one because bending down resist that one, that axis. So this one. So the moment is equal to 300 Newton meter. Then you look 1, 2, 3. How does it affect to that surface there? That surface area there. We have done this so many times. That one, 3 dimensions. So this one pulling down, my over. This is Y. So pulling down, right? So this sigma 1, my over I. Very clear, not?
Clear.
Surface, that one, surface there. What about the torsion here? Torsion here is going that way. So the shear is going that way. See that? Going that way. Up, down, down. See that? Here is horizontal. Your tau now. So this is your tau here. TR over J. Your T is 200. Your R is that one. Your J is pi D to the power of 4 over 32. Your I is pi D to the power 4 or 64. You got that? You got the value there. Whatever value is that, we got the value, and then 100 ini, this become a shear due to shear stress. VQ over IT. But it's got value there, but 0 there. It's only one. Are you with me?
Yes.
So, at the end of the day, your stress element there, you start with that one, you draw it, you stop, look from the top, put it there, you got like that. So this one is that one. This one is that one, MYY. Let's say the value here is 300, the value is 100, and then you finish it. Because no other things. So this must be the other side. This must be going away. This must be going away. This must be going away. We have to do that very quick. This is solid 1. Are you with me?
Yes.
TR over J, MY over Y, MY over I, VQ over IT, P over A, that one. You must do that very quick. And then only then you start the analysis. Imagine that you must do that in less than 5 minutes. And then you start the more circle. So what is that? 300 and minus 100. 300 minus 100. And then this 0 and positive 100. There's your X, there's your Y. There's more circle there. You can find what is your sigma 1, what is your sigma 2. Let's say the question say, I put a straight here there at an angle to that axis 30 degrees. So that axis for A is that axis 30 degrees. You see that?
Yes.
What is the value of strain here there? This is stress analysis, but you want to find the strain. So what do we do there? Convert sigma 1 and sigma 2 for the E1 and E2. Are you with me?
Yes.
You know that an angle, you know the X, you must put an angle there, the same angle, you must know X there first. X and Y first. Only then you know that that is your X direction, that is your X direction, that is your A direction. Where is A? 30 degrees. So 60 degrees there, that's your A. Show that 60 degrees. That's the original theta. 60 degrees from X to A. 30 degrees from X to A. Only then you read the value there. The triangle must shown be worked there. Same procedure again. But from the beginning, you must have what is sigma X, sigma Y, tau X, Y on your own. Because we have been very luxury. So many weeks now, we haven't calculated that one. It's just been given because there is only one. Are you with me, guys?
Yes.
So this weekend and tomorrow, we train on this. We train on doing this again, very quick. Can we?
We try to.
Okay. Stop for today. Okay, I give you some exercise on the thin cylinder and simple exercise. Do this one again.
Okay.
Find the principal stress, draw the element again, stress analysis again. Okay?
Okay.
Okay, thank you very much. Assalamualaikum.
Thank you, doctor.
Good luck for your test next week.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.